Dear students, now here let us discuss about Duhamel's principle. What is Duhamel's principle? It deals with the solution of non-homogeneous wave equation. It is considered utt minus c square uxx equals f of xt, where x lies in between 0 and minus infinity and plus infinity with a t greater than 0. Now, with the initial conditions ux0 equals, here the initial conditions are ux0 equals utx0 equals 0. Consider the initial conditions ux0 equals utx0 equals 0, where x lies in between minus infinity and plus infinity. So this is the initial condition. Consider the solution of this non-homogeneous wave equation. So consider the function vxt lambda. Solution. Consider the function vxt lambda, where t greater than lambda. Now, which satisfies the equation with respect to x and t with the vtt, which satisfies the equation vtt minus c square vxx equals 0. So listen, in Duhamel's problem that deals with the solution of the non-homogeneous wave equation utt minus c square uxx equals f of x. Now to find out its solution, first we consider a function vxt lambda, where t greater than lambda, which satisfies the equation vtt minus c square vxx equals 0. That's our assumption. With the conditions vx lambda equals 0, vx lambda equals 0, and vtx lambda vtx lambda equals f of x lambda. So these are the two initial conditions. Consider the function vxt lambda, where t greater than lambda, and consider which satisfies the equation vtt minus c square vxx equals 0, where t greater than lambda, with the conditions vx lambda equals 0 and vtx lambda is f of x lambda. Now, this Duhamel's principle says that the solution is vxt lambda equals 1 by 2c into, the Duhamel's principle says that the solution is vxt lambda equals 1 by 2c into integral along x minus of c into, as it is x minus c into t minus lambda to x plus c into t minus lambda g of s ds or f of s lambda ds. So which is the D'Alembert solution? What's the D'Alembert solution of vibration along infinite rod? That is, there is uxt equals half of f of x minus ct plus f of x plus ct plus 1 by 2c into integral along x minus ct to x plus ct g of s ds. That's we already see. So here the Duhamel's principle says that the solution of this non-homogeneous wave equation is nothing but vxt lambda is 1 by 2c into integral along x minus ct minus lambda to x plus ct minus lambda f of s lambda ds. This is our A. Okay. So here consider uxt. For consider uxt. Uxt equals integral 0 to t vxt lambda d lambda vxt lambda d lambda. Okay, consider this function uxt. Why? Because we know that uxt equals, we know that the D'Alembert's solution is uxt equals half of f of x plus ct plus f of x minus ct plus 1 by 2c into integral along x minus ct to x plus ct f of s or g as f of s ds or g of s ds, whatever may be. So this is D'Alembert's solution. Here consider uxt is integral 0 to t vx t lambda d lambda, and vx t lambda is defined as in this way. Okay, right. So what is ut? Du by dt. What is ut? Ut means, we know that there is a familiar result, that is d by, consider this result, it is d by dx of integral along alpha t to beta t f of x t lambda d lambda, f of x t lambda d lambda, that equals, it is f of x t beta t into beta dash t minus f of x t alpha t into alpha dash t plus integral along alpha t to beta t f t x t lambda d lambda. So this is a familiar result. Listen, d by dx of alpha t beta t f of x t lambda d lambda is f of x t beta t into beta dash t minus f of x t alpha t into alpha dash t plus along integral along alpha t to beta t f of x t lambda f t x t lambda d lambda. So this is the non-result. So you can integrate through ut, you can differentiate this function in the ut, means d by dt of integral 0 to t vx t lambda d lambda by using this argument. So what you get? Ut equals it is vx t instead of lambda, sorry, upper limit, that is it is vx t into beta dash t, means derivative of the upper limit, that is 1 into 1 minus integral, sorry, minus again vx t alpha t. What is alpha t? Here instead of alpha t, here it is 0 into alpha dash t, that's again 0 plus integral along 0 to t f t, here it is vt x t lambda d lambda according to this argument. Okay, but what is vx tt? Vx lambda lambda equals 0. Vx lambda lambda equals 0. Therefore, what is Vx tt? Vx tt is also 0. Clear? It is given Vx lambda lambda equals 0 for t greater than lambda, and therefore Vx tt, if the parameters are repeating, then Vx tt equals 0. Therefore, the first term goes to 0, this vanishing, this into 0, this also vanishing, only this term exists. Okay, so that means what is ut? Ut equals integral along 0 to t, it is vt x t lambda d lambda. Okay, this is ut. Now, under the same argument, what is utt? Again you can integrate it. So you can differentiate it with respect to t again. Utt by the same argument, then you have utt equals vt, it is vt x tt, okay, vt x tt plus integral 0 to t vtt x t lambda d lambda. Clear? Again, ut equals, you can differentiate it with respect to t, then by using this argument, then you have ut equals integral 0 to t vt x t lambda d lambda. Again you can differentiate this ut with respect to t by using this argument, then you have vt x tt. We know only vx tt equals 0, not a vt x tt not equal to 0. So vt x tt plus integral 0 to t vtt x t lambda d lambda. Okay. So therefore what is ut xt? means UTTXT. Here it is UTTXT equals VTXTT. What is VTX? Lambda lambda. That is f of x lambda. Therefore, VTXTT equals f of xt. Okay, f of xt plus what remains integral 0 to t. It is VTT xt lambda d lambda. Clear? Why? Because Vtx lambda lambda is f of x lambda. Therefore, Vtxtt equals f of xt. Agreed. Therefore, this gives utt minus c square uxx equals, it is f of xt plus integral 0 to t. What is Vtt? Here we know that Vtt equals c square vxx. Okay, Vtt equals c square vxx. Therefore, it is integral 0 to t c square vxx. Sorry, c square vxx d lambda. Then minus c square into again integral 0 to t vxx d lambda. Clear? Utt. What is utt? This one. But we know that Vtt. What is Vtt? Since Vxt lambda satisfies this equation, Vtt minus c square Vxx equals 0. Therefore, Vtt is nothing but c square Vxx. Okay, so you can cancel in these two. That means Utt minus c square Uxx equals f of xt. Utt minus c square Uxx equals f of xt. So this means, what is Uxt? That means Uxt equals, therefore it means Uxt equals integral 0 to t Vxt lambda d lambda. Why? Because it satisfies this condition. You get Utt minus c square Uxx equals f of xt when Uxt equals v of Vxt lambda d lambda. Okay. Therefore, Uxt equals integral 0 to t Vxt lambda d lambda. That means that equals it is, but Vxt lambda equals again 1 by 2c into this one. So it is integral 0 to t 1 by 2c into integral along x minus of c into t minus lambda to x minus plus c into t minus lambda into what remains f of s lambda ds. F of s lambda ds. So that equals integral 0 to t and again x minus c into t minus lambda to t plus lambda. That is nothing but that gives the required solution. Means its solution is of the form, it is 1 by 2c into x minus 2c. So x minus c into t minus lambda to x plus c into t minus lambda f of s lambda ds. Okay, so this is Dehaen's problem. Okay, so Dehaen's principle that deals with the solution of non-homogeneous wave equation. Clear? Okay. So this is a Dehaen's principle is an important result. Now there is a problem that done or that solved by using the help of this Dehaen's principle. The problem is ut minus kuxx equals f of xt. Ut minus kuxx equals utxt under the same argument. So consider solve the problem. Solve ut minus kuxx equals f of xt, where x lies in between minus infinity and plus infinity, and ux0 equals 0 with the initial condition ux0 equals 0 using Dehaen's principle. It is a one-dimensional heat equation. Ut minus kuxx is one-dimensional heat equation. Okay, you can solve this problem by using Dehaen's principle. How? So by using Dehaen's principle, first we assume the solution of the given problem is Vxt lambda. Let Vxt lambda where t greater than lambda be a solution of the given equation or solution of the problem Vt minus Kvxx equals 0. So in order to solve this problem by using Lorentz principle, first we assume that Vx t lambda for t greater than lambda is nothing but the solution of the problem, Vt or solution of the equation, Vt minus Kvxx equals 0. Okay, or Vt equals Kvxx. Under the conditions, Vx lambda lambda, sorry, Vt x lambda lambda equals Vtx lambda lambda equals f of x lambda. Clear? Now, we have the solution of heat equation of infinite order case. Its solution is, we know that the solution of heat equation of an infinite order case, it is V equals 1 by, we know that 1 by 2 into square root of k pi into t minus lambda. From there, it is only 1 by square root of square root 1 by 2 into square root of k pi t. Here, there is a third parameter lambda, so it is t minus lambda into integral minus infinity to infinity f of theta lambda. In that infinite order case, there is only theta. So it is f of, there is only uxt, here uxt lambda, another parameter is involved. So f of theta lambda into e power minus, there is k minus x square, instead of x, here it is x minus theta whole square divided by 4 tk. 4 instead of t, there is t minus lambda, 4 into t minus lambda into k dc. So this is the solution. We know that the solution of heat equation in infinite order case is V equals 1 by 2 into square root of k pi t into integral minus infinity to infinity f of theta e power minus of x minus theta whole square by 4 tk d theta. Here you can replace this t by t minus lambda because the third parameter is also involved in such that t greater than lambda. Okay, such that t greater than lambda. This is an important condition. Agree. So let uxt equals integral 0 to t vxt lambda d lambda, like the general solution of Lorentz problem. Okay, Lorentz principle. So let uxt equals integral 0 to t vxt lambda d lambda, where vxt be a solution. What is vxt? Vxt be a solution of ut minus or vt minus kvxx equals 0, or vt minus kvxx equals f of xt. Okay. So what is ux? Uxt equals integral 0 to t vxt lambda d lambda, and ux equals, what is ux? Ux equals integral 0 to t, it is vx x t lambda d lambda. Okay. What is ut? Ut equals, we know that integral along alpha t to beta t, so d by dx of integral along alpha t to beta t f of x t lambda d lambda equals. Okay, by using that argument, we have ut equals, so it is vxt t into 1, it is vxt t into 1 minus vxt 0 into 0 plus integral 0 to t, it is vt xt lambda into d lambda. Why? Because we use the idea d by dx of integral 0 to t f of x t lambda d lambda is nothing but integral 0 integral alpha t to beta, so it is f of x t beta t into beta dash t minus f of x t alpha t into alpha dash t plus integral alpha t to beta t v f t x t lambda d lambda, by using that result. So what is Vx lambda lambda dt? Here Vx dt. So ut equals Vx dt into 1 minus Vx t0 plus integral 0 to t Vt x t lambda d lambda. So that means it is 0. The first term goes to 0. And ut equals here Vx dt. This Vt x dt equals f of xt. Now it is ut equals f of xt. It is f of xt plus integral 0 to t Vt x t lambda d lambda. Why this is so? What is Vx dt? It is Vx dt. You know that Vxt be a solution of ut minus kuxx equals f of xt. Vxt be a solution of ut minus kuxx equals f of xt. Therefore, ux equals integral 0 to t. That is ux. Yes, integral 0 to t Vx x t lambda d lambda, and ut equals Vx dt into 1 minus Vx t0 into 0 plus integral 0 to t Vt x t lambda d lambda. Okay. Therefore, ut equals, that means what about the Vx dt? Vx dt equals f of xt. Vt x lambda lambda is Vt x lambda, Vt, the given condition, Vx lambda lambda, not a Vx lambda lambda, Vx lambda lambda equals f of x lambda. The boundary condition, there is a small change in boundary condition, Vx lambda lambda equals f of x lambda. Therefore, Vx dt equals f of x dt. That means, this means Vx dt equals f of x. Okay. Therefore, ut equals f of xt plus integral 0 to t Vt x t lambda d lambda. That means it is equals f of xt plus, what is Vt x t lambda? Vt equals kvxx. So it is integral 0 to t kvxx d lambda. Okay, kvxx means kvxx x t lambda d lambda. F of xt plus integral 0 to t kvxx x t lambda d lambda. Why? Because it is the solution of this equation. Okay. Therefore, ut minus kuxx equals, what is ut? It is f of xt plus integral 0 to t kvxx x t lambda d lambda minus k into